So, checking out an expression like this, we saw this yesterday, and we used the distributive property to change something like this to something like this. This is just showing the box method. All right? So, Will, we never saw anything but addition yesterday. So today, guess what we're going to see? Subtraction. But in terms of concept and stuff, an area model doesn't make quite as much sense because negative area, but it still works the theoretical part of an area model. So we can use the negative. If you're good with yesterday, today's not going to be a big leap forward. So I know negative 5 doesn't make sense kind of for an area model, but if I have an x minus 5 by an x times x squared. X times negative 5, negative 5x. It still works in theory, okay? Everybody feeling pretty good about that? You can also continue just distribute. X times x is x squared. X times negative 5 is negative 5x. This is how I tend to roll, but this is a great way to visualize and problem solve and see why it works, okay? That's why we do it. Number sense. Okay, so I want you to show that x minus 1 times x minus 1 is equivalent to x squared minus 2x plus 1. And then I want you to practice doing that for A, B, and C as well. So finding the distributed form. You're going to find the equivalent expression. And we're going to have some words for the differences of these. We're going to hash that out today too. Let's check out these functions. So the x minus 1 times x minus 1 also could be written like this. It could be written like this. Okay? That's not the answer. I'm just showing you this is the same thing. I've got x squared minus x plus 1. X squared minus 2x plus 1 is what it would be equivalent to. Any questions about any of those parts? So I've got x squared minus x plus 1. All right. So for A, x squared minus x minus 1. So I have an x squared minus 1 for that one. So notice I had a plus and a minus. What happened to that linear term? It canceled out. Okay, next I have x squared plus 3x minus 2x minus 6. I did that and that. So I get x squared plus x minus 6. I've got a quadratic, linear, and constant term. The last one, you are not going to be very successful most likely unless you rewrite it like this, which is x squared minus 2x plus 4, x squared minus 4x plus 4. Most common mistake is this term's missing. That's the most common mistake. Well, if you just look here, it looks like an x squared plus 4. I get it, but it isn't just an x squared plus 4. All right, any questions on any of these? Yeah, Willa.
Can you show us how you got B? Because I had
B?
x squared plus 1. Because the x's, I thought the x's canceled out each other and then...
No, so if the x thing messes you up, you can say something like puppies. So 3 puppies minus 2 puppies.
1 puppy, 2 puppies.
So there's still an x there.
Yeah, so I had x squared plus 1.
Plus 1x. There's a puppy left over, not just one. It's not like, so 3 puppies minus 2 puppies isn't 1, it's 1 puppy.
The 3 and the 2 are connected to the x.
No, they're not magically connected. What 3x means is x plus x, right? And what minus 2x means minus
Yes, but they're not connected, so how did you get them to
2 x's cancel 2 x's, leave us with 1.
Well, how did you get them to connect if they're not magically connected, but they're in the same parentheses?
They're not.
Why didn't you just take the number?
No, 3x means 3 x's, x plus x, right?
How do you get 3x from the equation?
Because x times 3 right here, I distributed my x to my 3.
But that says x plus 3, not x times 3.
Correct, but the distributive property allows me to multiply across parentheses and get the same answer, right? Remember the first box we looked at yesterday? This is good. There was something like a 6 and like a 3 and a 2, and it's 6 times 3, and 6 times 2 is equivalent, right? 6 times 3 plus 2. It's for the same reason. We can distribute across the parentheses. So it's that property that property allows us to get it out of the parentheses and still be true. Okay, that's cool. That's a good question. All right. So next what we're going to do is You might have noticed then we're seeing quadratics in a couple ways. We've got, even if you have not been using the terminology, standard form. And this whole column here is written in standard form. We also have factored form. And this whole column here has some factored form, but definitely not standard form. So what you're going to do, you're going to highlight some reasons why you know that these are in standard form. Okay, standard form. How do you know? And then you're going to highlight some reasons how you know some things are in factored form and how you know. Let's go. Okay, so what do you notice about the standard form stuff, guys? Micah.
It does not have any parentheses and doesn't look like it can't be simplified anymore.
No parentheses, can't simplify. Okay, I would agree with that. Anything else with standard? Yeah, great.
Oh, I was gonna say something for
Okay, what's something you notice about the not standard form or the factored form?
there are parentheses.
Yep, parentheses. And then what about this one? That one looks different, right? We have a binomial times a binomial, and we have a binomial times a monomial.
What the?
Well, here's why.
That's not like only.
If you were to look at something like this, what do they have in common? What factor? What are they both? They're both being multiplied by what number? X, right? So I could factor out x and get an x plus 9. And we'll practice this later, right? Not today. But the factored form has the factor out of it. The standard form has the distribution happening. It's all in there, okay? So here's standard form. This is going to look crazy, right? Let's talk about how these words make sense. See this ax squared plus bx plus c? This is important. A is this coefficient, b is this coefficient, and c is this constant, okay? We're going to use this later for the quadratic formula. So kind of how there's like y equals mx plus b. We had y equals ab to the x. Now we have ax squared plus bx plus c. It's just the form it's in. And notice it says the only one that can't be 0 is a. That's because we need a square. B can be 0 because 0 times something is 0. We don't need this term. This can be 0 because we don't need this term. This is the term we have to make it quadratic. So a cannot be 0, but b and c can be.
Why can't A be 0?
Because 0 times x squared gets rid of the x squared, then it's not quadratic. Yeah. With factored form, okay, we have the two factors. Notice that factored form has these parts from our model, the divided out parts, not the multiplied parts, okay? So it's two linear factors. X itself is a linear factor. So if I had like an x and x plus 1, these are both linear. A slope of 1, a slope of 1, right? So when it says linear, it's broken up into x to the first power things. All right? Notice x to the first power, x to the first power. This is factored form. You may notice there are parentheses, right?